Hello everybody. Today I will give the last lecture about water treatment. Today's objective is to understand sedimentation, to understand Stokes law, understand Newton's law, and apply examples to utilize the Stokes and Newton's law. Sedimentation is the process in which majority of particles will settle by gravity within a reasonable time and be removed. Particles density greater than 1000 kg per meter cube will eventually settle, and the particles less than 1000 kg per meter cube will float to the water surface. In water treatment, there are two common types of settling. First one is discrete particle settling, and the second one is flocculant settling. Today, we will speak and discuss the further details about discrete particle settling. Discrete particle settling occurs when particles are discrete and they do not interfere with one another as they settle. So they settle individually themselves. The movement of a particle in water is determined by a balance of three factors: downward gravitational force, an upward buoyancy force, and upward drag force. The settling velocity of particles in liquid can be described by either Stokes law or Newton's law. Stokes law is applicable for spherical particles when the Reynolds number is less than or equal to 1. Which is showing the laminar flow. Stokes law has limited use because conditions in treatment facilities are not laminar most of the time. Newton's law is used to determine the settling velocity of particles when Reynolds number is greater than 1, which is corresponding to the transition or turbulent flow. Here is the table showing everything related with the Stokes and Newton's law. In the first column, you will see the equation which is explaining how a settling velocity as a meter per second can be described, and the equations have been given for both Stokes' law and Newton's law. And the terms which are used in the equation have been explained in the column under the terms section. And the unit of each term has been also provided here. And the next column is the calculation of the drag coefficient. And the equations are different for Stokes' law and Newton's law, and the calculation of drag coefficient has been provided on that column. Please look at the equations carefully. And applicability of the laws have been summarized in the last column. Stokes' law can be used for laminar flow once the Reynolds number is less than 1 or 1. And the Newton's law can be used when the Reynolds number is bigger than 1, which is corresponding transition and turbulent flow. Now let's try to have some examples about the Stokes' law and Newton's law. The question is here, asking the terminal settling velocity for a sand particle that has a diameter of 100 micrometer and density of 2,650 kilometers per meter cube. And the water temperature is 10 centigrade degree, and the density and viscosity of water at 10 centigrade degree provided on the slide. Here you can see the solution. By using the equation provided in the table that I already showed, you put the numbers and calculate the terminal settling velocity. And here the settling velocity have been calculated as 24.8 meter per hour. But we must verify the flow of condition to ensure Stokes law is applicable. That's why Reynolds number is calculated to verify if the particle settling is under laminar conditions. By utilizing the Reynolds number equation, you will get 0.53, and which is less than 1. That means laminar flow exists and Stokes law is applicable in this example. So we can tell that this particle settling velocity is 24.8 meter per hour. Now it is second example, and it will show you how a Newton's law can be implemented. And the question is, calculate terminal velocity for a sand particle that has a diameter 200 micrometer and density 2,650 kilometer per meter cube. The temperature of water is 15 centigrade degree, and similar to previous example, density and viscosity values for 15 centigrade degree water has been provided on the slide. Solution is here. We start by calculating the terminal velocity of a particle by using the Stokes law as provided on the table. And we put the values which has been already provided at 15 centigrade degree into equation. And this terminal settling velocity have been calculated as 113.8 meter per hour. However, we have to check the Reynolds number to verify if the particle is settling under laminar condition. So Reynolds number calculated, and the outcome is 5.55. I suggest you to make this calculation on your own to get the confidence of using equations and increase your familiarity with these laws. Because Reynolds number have been found more than 1, which is 5.55, that means Stokes law is not valid. That's why we need to calculate the settling velocity by using the Newton's law. But we need to calculate the drag coefficient, which is provided in table. So drag coefficient have been calculated by using the equations which is on the table, and it has been found as 5.94. And we use the terminal settling velocity equation, which is for Newton's law. And finally, the settling velocity have been found as 97.1 meter per hour. Because settling velocity cannot be determined explicitly, a trial and error method should be used. The Reynolds number is calculated again, then the drag coefficient, and corresponding terminal velocity are recalculated. After several iterations, a convergent answer is obtained. For this example, the answer becomes converged at the 6th or 7th trial and has a value of 86.5 meter per hour. You can see here the number of iterations, calculated Reynolds number, which is dimensionless number, and corresponding drag coefficient number, which is also dimensionless, and terminal settling velocity by using Reynolds number, by using the equations belong to Newton's law. So as you can see with the trial, the velocity, settling velocity value is changing, but they are becoming stabilized on the 6th and 7th trial. So we can tell that the settling velocity for these particles are 86.5 meter per hour. Thank you for listening. See you on the next lecture.